Okay, so I think with a bit of luck and fair weather, I may well be live now. So as people are starting to file in, if you can sign into the chat, and I'll say hello to you. If anybody can tell me if you can hear me. If you can sign into the chat, and I'll say hello to you. If anybody can tell me if you can hear me. Just typing a few things in, just so that you can we can interact. If you can tell me if you can hear me, okay. And once somebody confirms to me that you can hear me, then we can. Anne, thank you very much. Hi, Anne. Thank you very much for confirming that you can hear me. If you can hear me, okay. Right, I've just I can hear me as well. I've got it on in the side. I've just turned off the sound, so I don't want to hear my voice any more than you do. Right, okay. So as I said, if you can sign into the chat, and I'll say hello to you. And while people are filing in and taking a seat and doing all the things they need to do, just I'll ask you a couple of quick questions. First, how do you need to clean data often? And if you do, how often do you clean data? So the first question, do you need to clean data often, and how often? How often is that? If you can tell me in the chat box. I'm going to ask another question as well. While you're thinking about that and typing it in, next question, how long does it take to clean your data? Does it take you hours, days, weeks? For me, when I first started to clean data, it typically took me about 2 weeks to clean it. This was cleaning manually. So I would look at the data set by eye, and I would spot errors, and I would clean them by hand, typing them in. That was a long time ago. I don't do that anymore. Okay, Anne, I need to clean data every time I use it. Biggest part of the job. Yes, you're absolutely right. Hi, Doc. You're absolutely right, Anne. It is the biggest part of the job. Data scientists, we are told, typically spend about somewhere between 60 and 80% of their time cleaning data. So it is a huge problem. Doc, yes, you can hear me. I'm Doc, and as a data scientist, I clean data all the time, and it takes too long. Yes, it does. It's very, very unsexy. Nobody likes doing data cleaning. I don't like doing data cleaning any more than anybody else does. In fact, that's why I set up my company, because I hated data cleaning. I came up with a much better way of doing it, and I want to go out and teach the world how to clean their data in a much, much faster way. Okay, so do you need to clean data often is the first question. And the next question, how long does it take to clean your data? Right, so does it take you hours, days, weeks, months? I hope it doesn't take you months. Shouldn't take that long. Even with a really huge data set, it shouldn't take months. And a third question, which apps, functions or formulae are the most useful to you? I'm not necessarily thinking about Microsoft Excel. Most people do start off doing their analyses, their data cleaning, their data storage, all the stuff that you do with data. Pretty much everybody starts with Excel. But if you use other tools, other applications, what do you use? What functions and formulae are most useful to you? For me, I used to switch between Excel and Minitab. There's a certain way of working in Minitab where you could define a translation table, so that you could make translations of data from different formats. So I might say, for example, if I needed to analyze data in integer form and I've got it in text form, I might have, for example, small, medium and large, and that's no good to me. I need it in 1s, 2s and 3s. There's a data format within Minitab that allowed me to go, I want you to translate small into 1, medium into 2, large into 3, and that was really, really very good, very quick. Of course, the only problem is that your data have got to be clean in the first place to be able to do it. and it's got to be case controlled. But nevertheless, it's a really good tool. So while everybody is logging in, I'll just quickly go through the 3 questions again. Do you need to clean data often? And if you do, how often? How long does it take you to clean your data? Is it hours, days, weeks, months? And finally, which apps, functions or formulae are most useful to you, whether it's Excel or something else? Anne, what do you use? What particular applications do you use? Which functions and formulae are good for you? And what about you, Doc? What do you think? Which apps or programs are good for you? Okay, so as people are filing in and sitting down and getting comfortable, I guess I should make a little bit of a start. I'll introduce who I am. My name is Lee Baker. I'm the CEO of Chi-Squared Innovations, and I've been working with data for about 20 years now, so that means I am very old. This webinar is all about the essential principles of data cleaning, and that's what we're going to go through today. And what you're going to learn is how to collect data efficiently. That's the first point. Why am I talking about data collection? This is about data cleaning. So why do I mention data collection? Well, actually, it's a really, really important part of data cleaning, because if you collect your data poorly in the first place, you're going to introduce a lot of errors. So then you've got a lot of problems to deal with in your data cleaning. So if you can collect data more efficiently, more cleanly, then you've got a lot fewer problems with data cleaning. So collecting data is obviously a really important part of it. So I'm going to talk about how to collect data a lot more carefully and a lot more efficiently than maybe you have been doing in the past. Also going to learn how to organize your data. When you upload data into statistics programs, your data's got to be organized in a certain format, and if it's not, you can't use the program. So you've got to have it organized in the right way. So we're going to show you how to organize your data. And I'm also going to show you how to reduce Excel entry errors by just being organized and having a few basic rules by which you can collect your data and enter your data and clean your data. Okay, so Doc, thank you very much. He says uses something called FreeSite. I've never heard of FreeSite before. I will look that up and check out what that's all about. And Anne, you use numbers a lot because you can embed images into the cells in numbers. Numbers. It's not numbers as in numbers. It's a program, numbers. Okay, that's another one I've not heard of. I'll look that one up as well. You can embed images into the cells in numbers. Helps you sort a wide range of organizational data to keep it stacked up accurately. Then just use a load of sorts and columns. And importing CSV files is something that obviously you're going to have to do that a lot. Okay, thank you very much. FreeSite and numbers, interesting programs. I'm definitely going to look those up and see where we go. Numbers is Apple's Excel. Oh, okay. I can't look that up then. I can look it up, but I can't use it. I don't have any Apple devices. No Apple laptops or anything like that. So I will have a look at it, and we'll see where we go. Okay, so to get the best out of this workshop, I would encourage you to turn phones off, close your browser tabs, close the door, make sure that you're not disturbed, have a nice big cup of coffee handy, and feel free to take notes. Okay, just a little bit about me before we start on the talking about the actual data cleaning part, just so that you understand a little bit more about my background and why I'm qualified to talk about data cleaning. Well, as I said, I've worked with data for about 20 years now. I've worked on lots of different projects with lots of large databases. I worked on the Visible Human project, I've worked on the Human Genome project, and on a European soils database. And these were all, at the time they were called big data. Of course, big data is a moving target, and big data back then is not big data now. Big data now is just so big that it's really difficult to deal with. You need specialized tools. I didn't have those specialized tools back then, but nevertheless it was called big data back then. And once I'd done a lot of work with all of that, I then moved on to becoming a medical statistician, and I did that job for about 7 years. My job was as a medical consultant, a statistical consultant. I worked across the whole hospital, and people from all departments would bring me their data. So a lot of medical data, but there were the very, very varied types of data. But pretty much everybody got the same problem. They needed to get answers out of their data, but before they could start, they needed to clean their data, they needed to pre-process it, make sure it's in the right organizational status. And it used to take a ridiculous amount of time. I never sent anybody away. I probably should have done. Whenever people brought me a data set that wasn't prepared, I probably should have sent them away and said, no, go away and clean it and get it all ready for me to do the analysis. But I never did. I worked with them closely. I did all the cleaning and all the pre-processing before I did all the analysis. But as I went along, I taught them how to do it for themselves. I taught them all about the problems that they got with their data set and how to get around those problems. And then next time they brought me a new data set, maybe 6 months later, it was in a much better condition. And my job gradually became easier and easier because I was working with them. Okay, so as I said, all these data sets needed cleaning before we could do anything. And it was typically about 2 weeks per data set to clean. This is a ridiculous amount of time to spend in cleaning a data set. If you were to go to your boss and he said, how are things going, he asks you, and you say, well, I've been spending the last 2 weeks analysing this data set, and I really think I'm making progress now. He'll give you a pat on the back and say, good job, stay with it. If you were to say to him, I've been spending the last 2 weeks cleaning this data set, now I think I'm making progress now, He'll just kick you up the butt, because 2 weeks cleaning a data set is just ridiculously. It's just a ridiculously long time. But this is how long it takes if you're cleaning it manually, and if you're not experienced, if you don't have a process, and if you don't automate or at least semi-automate your processes. So there are ways in which you can make the whole thing go very, very much quicker, very much easier. And I'm going to start taking you down that path now, and we're on the first steps to doing that. So as I said, over those 7 years I worked with lots of people. I eventually developed a system to enable me to get data analysis ready really quickly. I could do it I got it down from 2 weeks to typically a couple of hours. So really very, 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 very quick. And it was a process that you could repeat time and time and time again. Really, really, actually a very simple process, but very, very powerful. And no programming required either. I didn't program this in other, in Java or in Python or whatever. This was all just in Excel. So very powerful, very quick. And I taught the other researchers how to reduce the errors and mistakes in their data, and it made my job a lot easier. I fine-tuned it over several years. I used it with hundreds of. I taught it to hundreds of researchers over hundreds of data sets, and I'm going to start taking you through the first steps of that now. And these first steps: how to collect data efficiently, how to organise your data, and how to reduce Excel entry errors. I'm going to start looking at this. Okay, just before I do, I'm just quickly look and see if there's any more questions. By the way, if you do have any questions at all, feel free to type them in, and I will answer your questions as we go along. There'll be plenty of time for questions at the end, but I will answer them as we go along. Okay, and so Anne reckons that numbers is better than Excel. Okay, good. Pretty much everybody starts with Excel, but after you've worked with it for a certain amount of time, you start to realise the limitations in it, and then you move on from it. You move on to doing other things that make it much quicker to do your data cleaning and your analyses. But pretty much everybody starts with Excel. Okay, so I'm going to switch over to my PowerPoint. Hopefully I can get all this right. Okay. So, the essential principles of data cleaning. This is what we're talking about today. So we're going to talk about how to collect data effectively. We're going to talk about how to clean your data and how to code and classify your data. We're also going to talk about your data being part of this thing called real life, and that your data, real life has rules, and so must your data. We're going to talk about that. And then I'll mention right at the end another webinar I'm going to do, another free webinar I'll be doing next week, and I will also give you your free webinar bonus right at the end of this webinar. Okay, so how to collect data effectively. First step, you've got to record data on paper first. Well, that is if you're working in in real life. I know a lot of data these days is collected completely digitally, and that's okay. If you collect data in the digital realm, you probably got a minimum of problems, a minimum of data cleaning to do. But for those people that still collect data in the real world, quite often you have to still record data on paper first. It's a really, really important step, because you don't just get a blank piece of paper and a pen and just start scribbling notes down. You think about your study, whatever the study happens to be, and then you think about the data that you're going to collect. You think about the question that you're trying to find an answer to, and what data are we going to need to be able to answer that question. So you then start to get a feel for which pieces of data are important and which pieces of data are not important, and then you can start getting them together on a piece of paper. And when you do that, you can start to put them together into groups. So you've got a certain type of data, and then other types of data, and other types of data still. And once you do that, and you start to look at these different groupings of different types of data, you start to see, okay, have I got all the data that I need? Is there something I'm missing here? You can go and take it to somebody else and say, right, this is the question I'm trying to answer. Have a look at this. Is there anything that I'm obviously missing? Is there a piece of data here that I'm going to collect that actually is not pertinent to that question? So you get a chance to really have a good think about your study before you even start collecting your data. And this is the paper process. It gives you a really good chance to really, really nail down exactly what it is you're trying to collect. So record data on paper first if it's appropriate for you. It may not be, but if it is, record data on paper first. And when you've done that, you can transfer it into electronic medium. And we're going to talk about Excel here because pretty much everybody starts with Excel. Okay, so Anne is just starting to use OpenRefine. Yeah, OpenRefine. Yes, I know that program. It's got a bit of a learning curve to it, but it is very, very powerful. My only concern with that is it's still a little bit too manual. I feel it's more powerful than Excel, but there are other things that's more powerful than OpenRefine that can get your data cleaned much, much quicker than that. Okay, so that's so when you transfer your data to electronic medium, when you've done that, it should look something a little bit like this. right? So that this is an example of a data set which is quite well behaved. It's not perfect. There are some problems with it. There's still some work to do with it, and still some data cleaning to do. But there are some features about this particular data set that make it actually quite a good start. And we're going to go through the features of this, and you should be able to recognize, hopefully you should be able to recognize why this is a good start already. But we're going to go through the various steps anyway, just so that you fully understand. Okay, so data collection. When you enter your data, when you get your data from your paper-based forms and you enter it into a single worksheet, enter it into Excel, you should enter it into a single worksheet. You shouldn't have your data breaking across different worksheets, because if you do, and you have to sort one of your worksheets by a particular column, that worksheet is now going to be out of sync with the other worksheets, and that can cause you huge problems. So we really don't want to do that. Make sure that you can enter your data into a single worksheet. Microsoft Excel, it allows you to have, I can't remember how many columns, but it's thousands of columns, or tens of thousands of columns, and over 1 million rows. If your data set is too big that it can't fit onto a single worksheet, then you need a different solution anyway. Excel is not the medium for you. Okay? So in almost all circumstances, your data is going to be small enough to fit onto a single worksheet. It makes Excel a good tool to use, but make sure that you do enter it into a single worksheet and not breaking across multiple worksheets. And you should use a unique ID column. Right at the beginning, when you first start to set up your sheet, your column A, you should start off by calling it unique ID and start with consecutive integers 1, 2, 3, 4 and so on, all the way down to the bottom of your data. This is really, really important. Probably the most important reason is if you need to sort your worksheet by a particular variable, and you might do it by one variable, and then you have to resort it by a different variable, and then by a different variable. You probably will want to restore the original order that you started off with, so that you can find your data. And the only way to do that is to have a unique ID column. So you start with a unique ID column right at the beginning, and you know that you can always get back to the original order in your data set. There are lots and lots of other reasons why you would want a unique ID column, but that is probably the biggest reason, the most important reason. If you don't use a unique ID column, you might end up losing the thread of where you are within your data set, and your data set could end up being completely ruined. Okay, so when you enter your data, you should use one column per variable. So each column is an individual variable. Variable being age, height, weight, body mass index, whatever it is. But each column should be a single variable. Each column should just hold one type of data. So for example, you shouldn't mix types of data within a particular column. If you've got age and date of birth, you shouldn't try mixing them up in the same cells and within the same column, because actually they're different types of data and you might have to do different things with them. So make sure that each column is an individual variable. You can always create more. And you should use row 1 as the variable name. This is really important. If you were to upload your data into a statistical program, usually the first row is reserved for the variable name. If you haven't used a variable name, then your first row of your data will go into the first row, and that will be seen as your variable name. It might also cause problems with the statistics program. If your variable name breaks across multiple rows, so you might have a complex name, or you might decide to put other things in rows 2, 3 and 4, maybe the units or the type of data that you've got, If you do that, you're going to cause problems because rows 2, 3, 4 and all the other rows are reserved for data, where row 1 is reserved for the variable name. So make sure that row 1 and only row 1 is used for your variable name. And every cell should have something in it. So even if you've got a cell in which you have no data, should you leave it empty? Well, I would say that you shouldn't, because if you leave it empty and you come back a couple of days later and you see empty cells, you don't know if those empty cells are empty because you don't have data, or whether you're waiting for the lab, or what reason. An empty cell actually doesn't tell you anything. It just sits there winking at you saying, come on then, what's this all about? So what you need to do is, for every cell, if you've got a reason why there's nothing, where you have no data, you should put a code into that cell. My particular preference is to use letters. So if you've got a numerical column, you could use the letter A for data not recorded, B for waiting for the lab, the letter C for the data is incorrect, or whatever. Some people tend to use illegal numbers, such as -1, -2, -3, if all your numbers have to be positive. Some people use -9, -99, -999 for missing data. These are all codes. They all tell you something, and it's great to use codes, and it makes sure that every cell has something in it. But a number is still a number, and you can still do calculations on it. And if you've still got these negative numbers in your data set and you don't spot them, you do a calculation with them, and it's going to throw things out. It's going to throw your calculations out. So I tend to use letters for codes. And of course, when you've created your codes, you need to put your codes in a code sheet. Have a code sheet. Put all your codes in. Explain what your codes mean. I've got an example here of variable codes of -1, -2 and -3 and what those codes mean. It's really important. You shouldn't be expected to remember what all your codes mean. You've got to write it down somewhere. So you write it down in a code sheet, just right where your data is. It's in the same workbook. Okay, and sorry you've got to go, Anne. We will be doing a replay of this, and I'll let you know. I'll email you. I'll let you know when the replay is out, and then you can watch it at your own leisure. So okay, but thank you for joining us anyway, and you can catch us later on when you're ready. Okay. So I've just mentioned that you should keep your codes in a code sheet, but that leads me on to the next obvious thing, which is keeping great notes. So what is it that your study is all about? What is your primary hypothesis? When did you start collecting data? Who started collecting the data? How did you start collecting it? All these things are really important. So when you make any decision, when you think about your study and you make any decisions at all, make notes about what you've done and keep them in a note sheet. And when you enter your data, you have to be consistent. This is really important because I've given an example here of a particular variable for which the entry could be either the word positive or the word negative. And I've just put a few possibilities of how you could write the word positive, pos, positive, plus, positive with a capital P, with a small p, pos with a small p or a capital P, or all capitals. There's so many different ways, but your statistics program are going to see all of these things as something different. It thinks you've got lots of different things when actually you've only got one thing. So if you can be consistent, be as consistent as you can about your data entry, then it's going to reduce the number of problems that you've got later. So be consistent about your data entry. Another thing you could do here is you can restrict the number of people that are going to enter the data, and make sure that each of these people understand what your data entry criteria are. You set up some standards. Tell them you want them to write out the word positive in full with a capital P at the beginning and lowercase for the rest. Tell them exactly how they should enter it, and it reduces the number of entry errors that you've got, the number of typos, and it reduces a lot of data cleaning that you have to do. Another thing is that you shouldn't guess. When you're entering numerical data, you should enter the data exactly as you found it. If you were to approximate with the data when you're entering it, you round it in your head. How many decimal places do you round it to? 4? 3? 2? Are there numerous people entering the data? Will they enter it to a different number of decimal places to you? You've just entered bias into your data set if you've done that. And not only that, if you've got a lot of numbers to enter, you will tend to abbreviate rather than rounding up or down, because it's easier to do that. But then actually you've just entered some more errors, some more bias into your data. So it becomes a real big problem when you try to, well, in this case it's not guessing, it's rather approximating, but you should enter your data as accurately as you possibly can. Now, in Excel you've got lots of different functions and formulae that can help you to round your data or do lots of calculations with it. But once you've got your data in, you can then use Excel. It can help you out with that, but keep it as accurate as you can right from the very beginning. I can't tell you the number of times I've received a data set where there's been a lot of zeros in the data set, and it's really caught my eye. And then I asked the researcher, why are there so many zeros in this? Oh, a zero means I don't have any data for that data point. Oh, that's a bit of a problem, because 0 is not a code, it's a real number. And if you try to do calculations, it's really going to throw out all your calculations and throw out all your accuracy. So 0 is not a code, it's a real number. Use other things. I have to keep saying you must use other things for codes, not zeros. Use letters. I use letters of the alphabet, A, B, C, and so on, to code my data. Okay, so I've talked quite a bit there about the basics of how to collect your data and how to enter your data into Excel to minimize the problems that you've got. Even when you do that, you're still going to have some problems. We are human beings after all, and we do make mistakes. It does happen. But even so, you might have inherited a data set from somebody else, and your data might not be clean when you receive it. So you've still got to go through processes to be able to clean your data. So let's go through some tips on how to clean your data. Right, okay, the first one is that when you have a data set, it is now a copy of your paper-based forms. It should, in theory, contain exactly the same information. So now what you want to do is you make a copy of that worksheet. Your original sheet, you call it raw data, and then you don't touch it anymore. You leave it as it is. The new data sheet that you've got, which is a copy of your raw data, you're going to start doing some work on that. You can call that cleaning in progress. There are a number of different reasons why you would want to do this, but one of the big reasons is because if you mess up your data cleaning and introduce some new errors into your data set, you've got a reset point. You can move backwards and say, oh, okay, I've just done a few hours work, but I saved my data in a previous worksheet. I've lost a couple or a few hours work, but I've got a reset point. I haven't lost everything. Okay, so it's really important. Make a copy of your data. And then when you start doing your data cleaning on your data, you can get to a certain natural stopping point where you say, okay, I've done some operations on that data. I can stop now. I've still got some more operations to do, some other pre-processing to do, but I can stop now and I can make a copy of this. And then you go along your next processing steps, and then you can make another copy. And by doing this, you find that you've got a chronological order to your data, to all of your worksheets. You've got a reset point. You've got multiple reset points that you can go back to, but you've now got a flow in your data so that you can see how your processes have continued from your raw data all the way through up until your data being analysis ready. And of course, when you've made a copy of your data, you don't want to do your data cleaning operations within the data sheet. You want to clean your data in a separate worksheet. The reason you do this is because if you were to do an operation such as find and replace, will that find and replace operate only on the selected column, or will it operate across the entire worksheet? You need to be really sure, because different functions do things differently. Some operate across just the selected data and some operate across the entire worksheet. If you get this wrong, you introduce new errors across your entire worksheet and you just created a huge problem. You have to scrap the worksheet and go back to a previous reset point. It could cost you hours. So you don't clean your data within the worksheet. You copy your data into a separate worksheet. Probably you should do it one variable at a time. So you copy over a column, you do some work on it. Once you're happy with it, you can copy it back into your worksheet, move on to your next column, and so on. If you've got a number of columns of very similar types of data, you can move a number of them all at once and then do some operations on all of those and then move them all back. That can be a very quick way of doing it. But what you don't do is clean your data in situ within the worksheet. Potential for disaster when you do that, so you clean in a separate worksheet. And when you found errors, you should report the errors back to the original source. The original source may well be that you've got a departmental database and you've extracted data from this database, you've done some work on it, you've done some data cleaning, and you've found some errors. Okay, in a few months' time, you might need to extract some more data, some similar data from this database, and you've got all the same errors as you had before. So all of the cleaning processes that you've had to go through, you go through all again on the same data. That's no good. So what you need to do is report the errors back to the original source. Make sure that the data manager understands exactly what these errors are, where they are, and cleans them in the original database. The next time you get the data out, it's much cleaner than the last time you got some data out. Okay, the next tip is to use Excel functions to do some of the hard work. Now we're getting into the realm of automating your data cleaning. When you collected all your data on paper, you did it manually, pen and paper. And when you transcribed it from paper into Excel, you did it manually. And through all that process, you introduced some errors. Hopefully not very many, but you introduced them. And the reason you introduced them is because you entered them manually. You are a human being. Now, what you don't want to do is use the same methods that introduced the errors to try to clean the errors. So if you try to clean errors manually, you probably introduce new errors. Maybe not as many as you had in the first place, but you will likely introduce some new errors, and then you're going to have to do some more data cleaning to clean up the errors that you introduced the second time. So you don't want to do that. As far as possible, you want to be automating your data cleaning processes, and this means learning to use the functions and formulae within Excel. You can use find and replace, of course, as we said, in a spare worksheet. You copy your data into a spare worksheet, use the find and replace, move it back. You can use remove duplicates to find out exactly what you've got within a column of data. If it's text data, you tell it to remove duplicates, and then you get a listing, a unique listing of what's in there. You can use that then to do a find and replace and make sure that you've got all your data cleaned. You can also use spell checker. How many people, hands up, how many people have used spell checker within Excel? I have to put my hand down because I've never used it, but you should. Spell checker is a really powerful tool, and you should use spell checker within Excel. Okay, so these are Excel functions that can help you to do your data cleaning in a more automated fashion. And Excel formulae, should learn to do those, to do the even harder work. So you can use trim, clean, substitute, upper, lower, proper. There are so many different formulae, but actually you'll probably only use 15 to 20 of them when you're doing data cleaning, at least in when you're doing the most basic data cleaning. When you get to the more advanced stuff, then yes, you might use one or two others. But if you've got 15 to 20 formulae to help you do your data cleaning, you probably don't need any more than that. So learn how to use these formulae to find out what's in your data, to clean out specific problems. And once you've done that, you can start to look at your data in terms of individual types of problem, rather than looking at an individual column and saying, "Oh, I've got lots of different typing errors in here." Lots of different. So you've got some empty cells, you've got some typing errors, you've got some numerical data within your text column, and lots of different types of error. Instead of looking down and starting to clean them up one by one as you go down by eye, you start to see how to clean each of these individual types of problem by a more automated method. And that's what happens when you start to get more experience using the formulae. You get a plan on how to clean your data using functions, formulae, more automated, within a process. Okay, so there are some tips on how to clean your data. So now about coding and classifying your data. Okay, as we said, you should code your data, and you should keep a code sheet. Now, there are a couple of different types of codes here that I'm talking about. One type of code is the codes that you enter when you've got an empty cell. What does an empty cell mean? I might have no data, or the data might be incorrect, or I might be waiting for the lab. So you might put in A's, B's and C's for all of those things to tell you why you've got an empty cell. But the data itself might need to be in codes. If your statistics program will not allow you to use text data, and you have to have it in integer format, then you need to have your data in codes. So I've got an example here of a code sheet in a way that I set up my code sheet. So I list all the variables here in column A. So we've got gender, menopause, cancer, estrogen receptor, tumour grade, and other things further down. And across the columns, I've coded things as zeros, ones, twos, threes. I've got a -1 and a -2, and further things towards the right. Okay, so what I've done is within my gender column, I've coded a male as a 1. So wherever the patient is a male, I've put a 1. Whenever the patient is a female, I've put a 2. When data has not been recorded, I've put a -1. When the data has been incorrect, I've put a -2, and so on. Further down in tumour grade, grade 1, grade 2 and grade 3 are coded as 1, 2 and 3. Well, that's easy to remember. 1, 2 and 3 is grade 1, grade 2, grade 3. It's not so easy to remember that in menopause that 1 is premenopausal status, 2 is perimenopausal and 3 is postmenopausal. Shouldn't have to remember these things. This is why we keep a code sheet. And if you organise your code sheet in this way, in a grid fashion, then it becomes really easy for you or anybody else who has to work with your data to understand how and why you've coded your data in the way that you have done. And classifying your data. You should understand your data types. Hopefully you will understand what quantitative and qualitative data are. I think these are pretty self-explanatory, but do you understand what ratio, interval, ordinal and nominal data are? I think you should. It's important that you learn what those 4 types of data are, because you're going to analyze your data once you get to the other end. And if you're going to analyze your data in a certain fashion, you're going to use a specific statistical test. So, for example, using if you're going to analyze one variable against another, it might be typical that you use a chi-squared test. Well, if you're going to use a chi-squared test for that data, what format should the data be in? Well, the data should be in an ordinal fashion, both columns. So that tells you how you're going to collect your data in the first place. If you collect your data in a different format to the format in which you expect to analyze it right at the other end, you might be collecting the wrong type of data for the statistical test that you're going to use. So this all comes into the idea of getting organized right from the beginning and really having a really good think about your study and thinking it through all the way from beginning to end. And once you've done that, you will know exactly which type of data you're going to collect, because you know exactly which type of statistical test you're going to use on these data right at the far end. And if you've thought about this, then you should be able to look at your data and say, I know exactly what type of data this is. It's ratio, or it's nominal, or whatever it is. Once you've classified your data like this, every column, you can then put it into a note sheet or into your code sheet, so that you know exactly what type of data you've got, and it becomes obvious then which statistical tests you're going to use. You might even want to write down which statistical tests you're going to use on your data. So learn about these 4 different types of data: ratio, interval, ordinal, nominal, and then you can use them. Okay, data is an abstraction from real life. Real life has rules, and your data must have rules as well. Okay? Oh, it's gone too far. So you've got to check that your data is sensible and conforms to real life rules. And what I've done here is I've taken these variables and I've calculated some descriptive statistics, very simply, so that I can start to get some kind of an understanding, a feel for my data. So what I've done is I've calculated a count of each of my variables. I've worked out the minimum, the mean, maximum. I've counted the number of negatives within each column and the number of zeros within each column. Okay? Now, of course, you haven't seen these data. You haven't seen this data set, so you don't know what problems you might have in it. But by doing some descriptive statistics, it can tell you what problems you've got in it, and it won't tell you where the problems are, but it can help you to identify them. So the first thing is we did a count. Well, there are different numbers of data points within each of these variables. That might be a problem. It might not. It depends on your data. It all depends on your boss as well. I had a boss that was really picky about this. He insisted that we must have exactly the same count for every column. Every cell must be accounted for. It was the very first thing that he would check within my descriptive statistics, that the tallies of all the data were all exactly the same. And if there was a data point that was missing, I needed to explain to him exactly why those data points were empty, why we didn't have any data for it. We had to track down every single piece of data that we could get. So that might be very important to you. The minimum. In here, in the age column, you've got a negative number. Well, nobody has got a negative age. So that is a piece of data that is incorrect straight away. And it becomes very, very obvious when you've done some descriptive statistics, because real life has rules. Over here in the height, we've got a maximum height of 19.53 meters. Again, nobody is that tall, so there is a problem with this data. Go in, find out what the problem is, find out where it is, find out how that data point got introduced into there. Clean it up, make sure it's correct. Then you can come back to your descriptive statistics and see what your new maximum is, now that you've cleaned that particular data point up. Is that new maximum sensible or not? Number of negatives. So there are 27 negative values here in gender and 32 here in age. Did we use negative numbers as codes? Maybe we did, maybe we didn't. But ultimately, before we can do any analysis on these data, we've got to be able to clean all of those out. So we've still got some work to do here because of the number of negatives. And we've got 15 zeros here in gender, and we've got 12 zeros in our height variable. Well, there shouldn't be any zeros in either of these. So again, lots of problems, lots of things that we need to work out. But rather than go into your data set and just start looking at it by eye and scrolling down thousands, tens of thousands of rows, trying to spot errors by eye, we use some descriptive statistics to tell us whether our data is following real life rules, to tell us what the problems are. And then we can go and seek them out, clean them up, and then we can move on. Okay, so they're the first steps to getting your data analysis ready. So we've talked about collecting your data and why it's important to be very careful about collecting your data. It's all about making sure that your data is it's clean in the first place, or as clean as it can be. And then we've talked about cleaning up those residual errors that are still in there, or if you've inherited a data set from somebody else and they haven't been as careful as you would be with your data collection. We've talked about the coding and classifying your data. We've talked about keeping notes, keeping codes. We've talked about making sure that your data follows real life rules, and how to use descriptive statistics to tell you when your data is not following these real life rules. So I hope that I hope that you already follow all of these principles, because it's great when people actually do all of these things. You end up with a data set that is it's clean when you start with it. There are a minimal number of problems with it, and you have so few problems. But that's not always the case, and experience has taught me over the years that actually most people don't follow these basic principles of data collection, data cleaning, data integrity. And if there's any of these that you don't use, I suggest you start using them. Okay, so I'm going to do another webinar next week, which will take us on to the next step after this. And the next step is how to organize your data to fast track your data cleaning. Okay, I'm going to be doing this on Tuesday the 16th of May. So this is 1 week tomorrow. Okay, it's going to be at 8 p.m. British Summer Time, which is 3 p.m. EDT. And in this webinar, you're going to learn how to organize and optimize your data worksheet. So this is the single worksheet that you put your data into. Okay, we told you before earlier in this talk that we put our data into a single worksheet, and we all our data is held within that single worksheet. Okay, so I'm going to show you how to organize and optimize that single worksheet, and then I'm going to show you how to use multiple worksheets so that you can really clean your data very much faster. Remember I said that you make a copy of your data set, you clean it so far, then you make another copy, and then you do some more operations and you clean it again, and so on. So you get a chronological flow into it. I'm going to show you how to do this, how to use multiple data worksheets to get things done much quicker, much more organized, get processes into your data cleaning. And I'm going to show you how to simplify your data cleaning processes to get your results much faster. For next week's webinar, to claim your spot in the webinar, you should go to this website here. I'm going to copy this. I'm going to paste it into the here. There. So it should now be in the chat screen. So you should be able to just hopefully click on that, and it go straight to. Excuse me. You should be able to go straight to that, and you could sign up for the next webinar. If not, I'll be sending out an email anyway. You'll still get it into your email. You can claim your spot on the next webinar. Okay, Doc is asking if this has been recorded and how you can get a copy. Right, it is being recorded. That's hopefully if all the technology has worked okay. It is going. I'm streaming it live into YouTube, and you can either find it in YouTube or I'm going to embed it into a page on our website. I will send you an email, and you'll be able to link straight to it and go straight to it on our site. Okay, so I told you that you can get a free webinar bonus, and the bonus for this particular talk is the practical data cleaning video course that I did, practical data cleaning ebook, and a cheat sheet. Now all of these are contained within the video course. Some of you may have already got all of these, and if you have, great. If you haven't, go and claim your free video course, your free ebook, and your free cheat sheet, and you can get them here. Again, I'm gonna copy this and paste it into the here. Okay, so there's the link there. You can click on that and go straight through. Or alternatively, if you scroll down the page, there is a box underneath which is a link straight to the practical data cleaning online video course. There's a box, and underneath there's a blue button that says enroll now. If you click on that, that will take you straight through to the video course, which I have made free. Okay, so thank you very much for your time. It's been really good. I've really appreciated that you've answered my questions, and that you've asked me some questions as well, that you've engaged. I'm going to hang around for another few more minutes after this is closed, and if you've got any questions, you can either put them into the chat box and I'll answer them, or alternatively you can email me, and I will get back to you in your inbox. So thank you very much for your time. This has been really good, and I hope that you'll join me for the webinar next week, in which we'll be going on to the very next steps. So thank you very much, and wherever you are, enjoy the rest of your day. Good night.